In this video, we're going to learn how to make phenotype annotations using Canto. A phenotype annotation captures how a genotype and the conditions of an experiment lead to a given phenotype. For example, the mutant Cat7-24 at high temperature conditions displays a monopolar spindle phenotype. To make phenotype annotations, you first must add genotypes using the genotype management. If you don't know how to do it, see the link in the video description. Then click on phenotype and indicate the genotype associated with this phenotype. We can choose from the drop-down or click on the magnifying glass to use text search. And then we have to find a FIPO term describing our phenotype. And if we don't find what we're looking for, we can try a broad term, abnormal spindle. Then we can refine from here. First, we make sure that the definition that is here is what we expect for the term name. Then we try to find a more specific one. So abnormal mitotic spindle and monopolar mitotic spindle. We make sure, again, that the definition is what we expect, and we can also sometimes find comments that give us tips for annotation. Then we click on Next, and if we think that these terms are too specific for what we want and we are satisfied with our pick, we click on Finish. If you don't find the term you need, request a new one by clicking on Suggest a new term. You can suggest a name and a definition for this term. Then we select the evidence code that explains what type of experiment was this done in, microscopy experiments, and finally in conditions add details about the experimental setup. This was done at 37 degrees in Y5S medium liquid culture. In the comment section, it's a good practice to indicate the figure or table where this phenotype is coming from. At this point, we can already save our annotation by clicking on OK, but it's good to check for annotation extensions. These are different depending on the term name. In this case, we have penetrance to indicate the proportion of cells that present the phenotype in the population. So here we can put either a percentage by typing it or use a qualitative value from this drop-down. We can also indicate the severity, which is how severe the phenotype is, by clicking there. There are many types of annotation extension, and you can find all our tips in the link in the description. We're going to focus on common ones like abnormal protein localization to a cellular component, for example the mitotic spindle. In this case, you will have an assayed protein extension in which you can indicate which proteins are affected. So for example, this Cat7 mutant may affect the localization of ACE1. This extension can also be used to indicate that the mutant protein itself is mislocalized. So for example, if I want to say that Cat7-24 mislocalizes in the spindle, I indicate assayed protein Cat7. Another example is abnormal protein-protein interactions. We want to indicate that this allele of ACE1 can affect the interaction of two proteins. So here I can indicate the two proteins affected, so Cat7 and PEG1. I can also use this extension to indicate that a given mutant disrupts the interaction of a protein with itself, for example, in the formation of a homodimer. Then I will select the same protein twice. Once we have created a phenotype annotation, Canto has tools to speed up the process for future ones. For example, if we want to create the same phenotype annotation for all the genotypes, we can click on Transfer and on the other genotypes to which we want to transfer this annotation with or without extensions by clicking here. Then we click OK. We have replicated the same phenotype annotation for other genotypes. We can also take an existing annotation and, for example, change the assayed proteins. We can click on copy and edit, remove these annotations and add new ones, say AS1, okay, and we have copied and edited this annotation.